All right, so now that we've gotten our UI image picker controller set up and ready to go, and we've also incorporated our Inception v3 machine learning model, we're ready to start getting some interpretations using that model. So the first thing I'm going to do is I'm going to go just below where we set the image view's image property to the image that the user picked. We're going to convert this UI image into a CI image, which stands for Core Image Image. And that's a special type of image that will allow us to use the Vision framework and the Core ML framework in order to get an interpretation from it. To do that, all we need to write is let CI image, so we'll just call it CI image, you can call it whichever you like, equal core image image, open bracket, and the image that we're going to be using to process is that user picked image that we got from earlier on. So the code as it is fine and it will work, but I'm going to add a little security feature in order to make it a little bit safer. So what I'm going to do is I'm going to add a guard statement in front of the let, and then I'm going to write an else statement that will trip if this part fails, i.e. if it's unable to convert our UI image that the user picked into a CI image. Now that shouldn't really happen, but if it does, we want to trigger a fatal error, and we also want to write a message saying something like could not convert to CI image, so that we know exactly what's happening. All right, so now that we've converted our UI image into a CI image, we're going to create a method that will process that CI image and get an interpretation or classification out of it. So I'm going to write this just above my camera tapped IB action. I'm going to create a new method, and the method is going to be called detect, and it's going to take only one parameter, and the parameter is going to be called image, and the data type will be a CI image. And what I'm going to do inside this method is I'm going to use the Inception v3 model. So all you have to do is to create a new object, going to be called model, and we're going to use the VN Core ML model as a container for our ML model, and our ML model is called Inception v3. So in this part where you've got a placeholder for ML model, you're going to write the model that was generated when we dragged and dropped in this Inception v3 ML model. So you can see it's already auto-suggesting, but you can also find out if you just click on this little arrow here, and you can see that our class that was generated is called Inception v3, and it's got a property called model. So now we've got Inception v3 creating a new object, and we're tapping into its model property. So now we have created an object called model using the VN Core ML model container, and creating a new object of Inception v3 and getting its model property loaded up. So basically this model is now what we're going to be using to classify our image. Now you'll see that if you write this line, you're going to get an error, and it's saying that this line of code can throw an error, and we're not handling it at all. So let's go ahead and handle that by typing try ? In front of this. So when we add try, it's going to attempt to perform this operation that might throw an error. If this operation succeeds, then the result is going to be wrapped as a optional. But if it fails, i.e. if there was an error that was thrown, then the result of this line will be nil. So to guard against those situations where this fails and we end up getting a model that is nil, we don't want to do any more image processing with something that with a nil model. So if our app does crash under those conditions, we want to know exactly why it did. So we want to send an error message to our debug console. So to do this, I'm going to wrap everything inside a guard statement. So now instead of if let, I've got guard let. And this means that if my model is nil, then I'm going to trigger an else statement that is going to throw a fatal error, giving me the message that maybe loading Core ML model failed. That way, I'll get it printed in my debug console and I'll know exactly which part of my code failed. So it's basically a way of allowing your app to exit, giving you plenty of information about what caused it to exit or to crash. And in fact, if you think about it, in this case, we could probably also benefit from wrapping it inside a guard statement, because in the cases where we can't actually convert our UI image into a CI image successfully, then we could end up crashing our app without knowing what caused it. So let's do the same. So if you remember how to add the guard statement and how it worked, then pause the video and add it now. So we want to throw a fatal error telling us in the debug console that we couldn't convert the UI image into a CI image. Now, if you don't remember how to do that, I'm going to show it to you now. So instead of simply let, we're going to call it guard let, and it's going to evaluate this statement. If it's true, then it's simply going to do nothing. But if it's false, then we're going to trigger this else statement. So instead of an if else, it's a guard else. And in here, we're going to throw a fatal error that tells us that we could not convert UI image into CI image. So now, if our app crashes because this failed, we'll know exactly what happens because we have that message in there. So you might be wondering where this VN Core ML model comes from. Well, it actually comes from the Vision framework. It allows us to perform an image analysis request that uses our Core ML model to process images. So the next thing that we're going to do is we're actually going to use this model that we're certain exists because this part didn't trip and our app didn't exit. So the next part will only happen if this was not nil. So here we're going to create a Vision Core ML request. So we're going to call it request, and it's going to equal VN Core ML request, and we're going to use the one that has a completion handler. So I'm going to hit enter. The model that we're going to be using is, of course, this model that we created earlier on. And if you now just click on this VN request completion handler placeholder and hit enter, it'll insert the code automatically for you. So now, as a part of our completion handler, we're going to get two things back. One is the request. So we're going to call it simply request. The next thing is an error. So we're going to call this error. And the code that we want to happen inside this completion block, i.e. when that request has completed, is to process the results of that request. So to do that, we're going to create an object called results. So let results equal request. So that comes from the completion handler callback dot results. And as you can see at the moment, its data type is an array of any objects. So we're going to make that a little bit more specific by, again, using the as question mark. And instead of being an array of any data type, we're going to make it an array of VN classification observations. And this is a class that holds classification observations after our model's been processed. So again, we want to use a guard to make sure that if this fails, our code exits and we know why it failed. So go ahead and wrap this line inside a guard statement as we did before. Pause the video and try it out. All right, so as we did before, all you need to do is add the guard in front of the let. And we're going to add an else statement that addresses what should happen when that fails. So again, we're going to trigger a fatal error, and the message is going to say, maybe model failed to process image. But if it succeeds, then we should have this object called results, which we should be able to print out into the console in order to see what results we got back. The last thing that we need to do is to actually perform this request. So you might notice that this request has a model associated with it, but it doesn't actually know which image to perform that classification request on. So this is what we're going to address now. We're going to create a handler that specifies the image we want to classify. So I'm going to write let handler equal vn image request handler, and it's going to take a CI image, and the image that we're going to input in here is the one that was passed into this method as a parameter. So the CI image that we're going to pass in. And that image is going to come from, of course, over here. So we're going to call that method in here a little bit later on. So the image that the user picked gets converted into a CI image, then gets passed into this method as a CI image, and then gets put into this handler to specify that it's the one that we want to classify using our machine learning model. So I'm going to use the parameter name, of course, which is image, and there is my image handler. And now all I need to do is just to write try using my handler to perform the request, which is, of course, this request that we created early on. So this line of code will work as long as you don't get any errors here. Now, as you can see, we've got the exclamation mark after the try, which means that we're forcing it to execute this line. But instead, the safer way to do this would be to wrap this execution inside a do catch block. So if you don't remember from previously, all you need to do is write the keyword do, and then enclose whatever you want to try inside the do block. And then you have another keyword called catch, which catches any errors that are thrown. And if there are any errors, then we want to print them into the console. And that's all you need to do in order to use a machine learning model to classify your image. So the last thing we need to do before we can run our app and test it out is that we actually need to call this beautiful method that we've just created. At the moment, it's not called anywhere, and we won't get any results back if we run it now. And in fact, you can see that this warning here is sort of giving you a hint as to the fact that maybe you have a bug in your code, because it's saying that this CI image that you created was never used anywhere. It says here's a fix. Instead of giving it a name, just make it a Boolean test. But that's actually not what we want. It's onto the right problem, i.e. we haven't used this anywhere in our code, but its suggested fix is not always the right one to go for. Instead, what we want to do is we want to pass the CI image into this method detect, so that the image can be used to be classified by our model. So very simply, all we need to do is detect, and the image that we want to detect is of type CI image, and that of course is this image that we converted from our user picked image. So now if we run our app, see what happens. All right, so here I've got the app, and I'm going to tap on the camera button. I'm just going to take a picture of my keyboard, and I'm going to click use photo. And so this is the data that we got back. And as you can see, it looks like a pretty big mess. But if you dig into it in detail, you can see that we've got a whole bunch of these VN classification observation objects. And if we go from the top, you can see that the first one, which was rated with 82% confidence, is computer keyboard or keypad, which is exactly what it is. Now the next one with lower percentage confidence is maybe a typewriter keyboard, which is also, I can see where it's coming from. And then you've got this one with 10% confidence, which is a notebook or notebook computer. So as you can see, this Inception v3 model is incredibly accurate in predicting what that image shows. Now, the only problem is that this is a tangle of data, so we have to make some sense out of it. So in the next lesson, that's exactly what we're going to be doing. We're going to be focusing on the task that we've set for ourselves in the beginning, which is being able to take an image of anything and classify it as whether if it's a hot dog or whether if it's not a hot dog. So we're going to do that in the next lesson.